Alrighty, this one's a little more complicated. 1 minus 2 sine squared theta plus cosine theta. Now recognize that we have a sine squared theta and a cosine theta. It would be great if they were both in terms of either sine or both in terms of cosine. Easiest way to make that switch is to turn that sine squared theta into a cosine theta. And how do you do that? Well, you need to think about the Pythagorean identity. Cosine squared theta plus sine squared theta equals 1. So if we rearrange that, we can subtract cosine squared from both sides to get sine squared theta equals 1 minus cosine squared theta. And we can just substitute that expression in for sine squared theta. So we have 1 minus parentheses, let's actually do this, 1 minus 2 parentheses, sine squared theta is equivalent to 1 minus cosine squared theta. So we'll need to distribute all of that in. And we still have our plus cosine theta equals 0. So let's go ahead then now and make that distribution. So we'll get 1 minus 2, negative 2 times 1 is minus 2, plus 2 cosine squared theta plus cosine theta equals 0. And now let's combine like terms. 2 cosine squared theta plus cosine of theta, and then a 1 minus 2 gives me a minus 1 equals 0. Now, you have options from here as to how you want to handle this. You could rewrite it and say move things around, move that around and figure out when it works just kind of intuitively. But the best way to do this is to treat this like a quadratic. So I'm going to make a substitution. I'm going to say let x equal cosine of theta. And then we can look at this as 2x squared plus x minus 1 equals 0. And now all we need to do is figure out what x values make this equal to 0. Well, what x values make this equal to 0, aka we need to factor this. So this is going to factor as, factor as 2x plus or minus something times x plus or minus something equals 0. We needed our two terms to multiply to negative 1, so they both have to be 1, either positive or negative, one of them positive, one of them negative. Well, which one needs to be positive? This one needs to be positive because we're going to get a 2x times 1 there to get a 2x, and then this one needs to be negative to get a negative 1 times x is a negative x, because positive 2x minus x gives me positive x, which is what I needed up there. So I have 2x minus 1 equals 0, which means that x equals positive 1/2, and I have x plus 1 equals 0, which means that when x is negative 1, we're also 0. So I found the two x values that make this quadratic equal to 0, but that's not good enough because I need to know what theta values make it equal to 0. Well, what do I know? We know that x equals cosine theta, so we can say cosine of theta equals 1/2, and we can say also cosine of theta equals negative 1. And now we just need to figure out where that happens. So again, draw a little reference unit circle. Where is cosine of theta equal to 1/2? Well, that happens here at that 60-degree angle, which is in radians, the same as pi over 3. And that will also happen, cosine of theta will also equal a positive 1/2 down here. So count by pi over 3's, 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. It will also be equal to 1/2. But we still need to figure out now where is cosine of theta equal to negative 1. Well, the only spot that happens is right smack dab right there, which is a radian value of pi. So I have three solutions to this: pi over 3, 5 pi over 3, and pi.